All right, guys, good morning. Couple of quick things to run down. So if you're watching this video on the correct day, today is Tuesday. I had to think about it because it's not really Tuesday when I'm recording this. So tomorrow, Wednesday, is actually your very first quiz. So just kind of be aware of that, right? So the calendar is up in the modules area that you can go back and look at. I think it's under just course information, one of those drop downs, and it has where all the quizzes and all the tests are, so you can kind of like keep an eye on that. But just in case it snuck up on you, didn't know that, like, yes, quiz tomorrow. What was I gonna say? Couple of things. Number one, I've noticed while grading the homeworks that some people look like they're just kind of copying the answers and turning it in. And I say that because there's some problems that it's very unlikely to be able to do without work. There's some, totally, I get it, like I understand completely. And again, I told you I give you that permission to do that. I just want to make sure that we are definitely doing enough of the problems that we are practicing them. Also, for this particular lesson, there were a couple things on the homework that may have looked a little different on the answer key, may have thrown you off. So I wanted to address those real quick. And if you perfectly understood the homework and had no issues, you can feel free to fast forward this a little bit. But one thing I wanted to point out was in this middle section where it said, state the mapping sentence. What was on the answer key, the other geometry teacher put that answer key together. They kind of just wrote it as rotation of a 90 or negative 90 and kind of wrote all these points. It would have been perfectly acceptable based off of these to have just written down this main statement. And so what I mean by that was this one, I noticed that the 7 and 4 are in the same order, but they're both opposite signs. And so I noticed that the rule that keeps X and Y the same order but opposite signs was that H, or that 180-degree turn, that half turn around the origin. So I would have been fine if you had just put an HO to do that. But generally, if you understood what was going on, I'm not so picky that you had exactly the right thing in that blank, just kind of for your own knowledge. This one, 4-8 to 4-8, obviously didn't change, so I believe the answer key said rotation 0, which is correct. But also, if you were following this exactly, then we would say that rotation 360 degrees around the origin would have also been a totally acceptable thing if we were just kind of copying what is said up there. So I just wanted to point that out so that didn't weird you out. The other thing I wanted to go over, at least do one of them, was the one with the graph. So this was number 19, and originally asked you to do it 3 different times. I'm not going to do it all 3 ways, but I did want to work through at least one more time, rotating it and talking about what that ended up looking like, just because there wasn't an example in the notes quite like it, but we have previewed we know how to graph, we know how to rotate points, and we do know how to find the equation based off things we've learned up till now. So you did technically have all the pieces to put that together, but for those that might like an example, I will work one of these out. So I'm just going to do it the very first way that says rotate it. Let's go with this negative 90, even if that's not the first way, that's what the third way. I'll do one that's negative and looks a little bit different. So the original problem was 3x plus 8. So going 1, 2, 3, 4, 5, 6, 7, 8. It was a little bit off the graph. Okay, no big deal. The slope is up 3 over 1, so that would be 1, 2, 3 over 1. This is clearly not a super helpful point for drawing this, so I'm probably going to count this sort of backwards. And I don't necessarily do anything fancy with counting slope backwards. I just look what the points are doing. So I was going to be down 3 over 1 going backwards. I'm just counting what it's doing. So down 3, 1, down 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3, 1. And that just gives me a little bit of some nicer points to work with. So we are rotating around the origin. So I like to just kind of remind myself that that's going to be important with what we're going to look at today when it's not the origin. In this case, it's doing negative 90. And so we mentioned that positive is always clockwise. So if this is negative, instead we're going counterclockwise. So I expect all of these points to rotate this direction exactly 1 click. So you, of course, can always turn your paper, but this means I'm going to turn my head 90 degrees 1 click. And I'm going to go ahead and represent that with all 3 of these points just to show you that. And I'll start with this one. So the way it looks like right now, I'm going negative 3, down 1. So when I turn my head 90 degrees this way, I'm going to count negative 3, down 1, and land here. The next point is at negative 2, up 2. So when I turn my head, this is negative 2, up 2. And then the last one, -1 up 1, 2, 3, 4. Turn my head, -1 up 1, 2, 3, 4. And you'll kind of notice there's still a similarity in the slope here, like the original was 3, 1. This is still having a movement of 1s and 3s. Oh, something must have been plotted wrong. Which one was it, Mr. Allen? 3, 1, 3, 1. 2, 2, 2, 2. 1, 1, 2, 3, 4, 5. 1, 1, 2, 3, 4, 5. See, I make mistakes too sometimes, but that's also, it's good to point out because those are the kind of things I double check, right? I could tell what the movement's supposed to be doing, something seemed off to me, I was able to go back and catch my mistake. So maybe I did that on purpose. It's okay. All right, so now I have to write the equation in this line. So I'm gonna read off the slope. This is a negative slope. It's now going down 1 over 3, right? I think on like the half turn rotation, the way it clicked, it still was a 3, but it was a -3 over 1. So being able to read that slope, it should have something to do with the same numbers, but they are kind of like flip-flop, possibly opposite sign, etc. And I picked this example to do as well because it was another example where the y-intercept isn't pretty, right? And it's pretty, if this is exactly at +2, done, it's +2. But if those points are not on that y-intercept exactly, you have to go solve for it. My personal recommendation is to always borrow the easiest double positive point if it's an option, right? I know it's not always an option. So for me, I'm gonna use the point 2, 2, even though any of these points, or even any other ones you would continue to do, would have worked. Okay, so borrowing 2, 2, the x value is 2, the y value is 2, here is the slope of -1/3, and I'm trying to solve for plus b. So I'm just replacing x and y. Again, multiplying fractions is top times top, bottom times bottom. So 2 equals -2 over 3 plus b. And as I solve that, I know I need to add this to the other side. So 2 plus 2/3 is what that b value is. You might be able to do some of that in your head, but most of us will probably need to common denominator that. That is a 3. So we're going to multiply by 3 over 3 and get 6/3 plus 2/3 is 8/3. So the answer for that, it was actually graph C on the homework. I just used the first graph. It was -1/3 x plus 8/3. Okay, like I said, that was technically a homework problem, and I don't usually jump on here and do a homework problem because you're like, hey, if I had questions, I would have been on that Zoom call, hello. But I did think it was worth looking at that one more time and kind of talking about that slope in case that's something that you need. Ooh, bells. Be glad you don't have to hear those at least. Okay, so let's look at today. I'm not going to give a whole lot of examples today just because we're already kind of running a long video here. So the main thing is we're going to look at rotating when it is not around the origin. So the way that's going to basically look is instead of that O, comma, the degree movement, they're going to give the specific ordered pair. So that's not telling you to like move left, right, up, down like it did for translation. This is telling you the ordered pair that's going to be the point we're rotating around. And then of course a -90 or 270, whatever it is, lets us know the direction and how many times to turn. All right, so I'm gonna just do that on 2 points, and then I really wanna spend our time doing an example about the lines, which really this is the homework page that you have for today. It looks like 6 questions, but you do have to do it 3 times each, but I'm gonna do like 2 of them with you, so it'll kind of shrink the number. And of course, the points go fast. It's really the lines I want you to spend your time actively practicing and making sure you're doing that right, because that's probably the newest thing compared to what you would have done in junior high with this. All right, so going back, they are taking the point 3, 5. So 1, 2, 3, 1, 2, 3, 4, 5. That's point A. And according to the problem, if you have trouble reading that from where you're at, this says rotating around the point 3, 1, 90 degrees positive. So this doesn't have a cute rule like -yx or something like that. So you could do a rule, but I promise it's really weird. You don't want to do it that way. How I approach these problems is I know that if this was around the origin, I would just count, turn my paper whichever way and count, just like I did in the example a minute ago. So what I like to do is I go to that point, 1, 2, 3, 1, and I literally draw what I'm going to call my fake origin. So for this part of the problem, I want you to pretend for right now that you cannot see this original black X and Y axis. You pretend like this blue is your X and Y axis. So if I ask, where is this point A? It looks like it's just up 1, 2, 3, 4. So I don't care that it's at 3, 5, really. I need to know where it is from this rotation point. So up 1, 2, 3, 4. Which direction am I doing? Positive 90 is this direction, one click. So I know that I'm reading this as up 1, 2, 3, 4, like I said. So when I turn my head, or you turn your paper, going up 1, 2, 3, 4, this is where A prime is located. Now, to answer the question, I do need to say where the point really actually is. So I am not reading it now from this fake origin. I am going to read it from the actual graph. Like, where did A prime actually go? It landed at -1, up 1. So -1, 1 is the answer to this question. You'll notice there's less of a connection in the original point with the final location. Okay, so that's just something to kind of keep in mind. Instead of just talking through that, let's go ahead and do it like just a second example and show you those steps again. So this one, the point in question is at -4, up 7. Okay, that is my point B. And if you can't see what this says too well on the screen, it says rotate about the point -2, 0, -90 degrees. So I'm going to go to -2, 0. So -2, 0. And again, I sketched this as sort of my fake origin for just this step of the problem. So right now I'm ignoring the original origin. We're going -90 degrees, so that's one click going clockwise. So that again means I need to turn my head this way, or turn your paper to make sure it's facing that same direction. So from this blue origin, I actually went left 2, up 1, 2, 3, 4, 5, 6, 7. So left 2, up 7, turn 90 degrees. Left 2, up 1, 2, 3, 4, 5, 6, 7. There is the location of B prime. You don't have to necessarily erase this. I'm just trying to point out that at this point, you no longer need to know where that fake origin is. I need to know where this actual point is on the real original graph. And that is located at the point 5, 2. Boom. Okay, so like I said, it's pretty much the same steps if you weren't using the rule before. If you were using the rule before, this is where you might need to go back and kind of play with just counting and turning and replotting the point. And like I mentioned in the other video, you come to an SAT question at some point that's rotating points, like you are literally not going to remember those rules anyway, so it's probably better to think about how to attack those questions. All right, last thing here. I'm not going to do the points because they're just examples like we just did. So the homework is going to ask you to do them a couple of times, 3 different times specifically. So it is kind of like doing 18 questions, but the points do go pretty quick. All right, so I'm going to do one more example of this line, and I will just do the first thing that it's asking instead of all 3. So I'm going to do like 4A, and I'll also do 6A so that I can kind of talk about those different forms again in case you're like, whoa, I remember that, but how do I do it? Okay, so we'll bring that back into your head. So this original problem starts at 5 with a slope of 1, 2, 3 over 1, 1, 2, 3 over 1. The rotation is at 3, 1, and it is positive 90 degrees. So I'm going to go to 3, 1 and make my fake origin. And I'm going positive 90 degrees. So I'm turning my head or my body or my paper so that I end up looking at it like this. And I'm going to just start with the closest point to me. So for my fake origin, that is left 1, 2, 3, up 1, 2, 3, 4. Left 1, 2, 3, up 1, 2, 3, 4. I'll do at least one more point so I can see what the slope is actually doing. This point is left 1, 2, up 1, 2, 3, 4, 5, 6, 7. 90 degrees. 1, 2, 1, 2, 3, 4, 5, 6, 7. I do feel pretty comfortable because how this is like up 3 over 1, and this does look like a 1 and a 3 general pattern. I feel pretty comfortable I did that right. And at this point, if you wanted to go like 1, 1, 2, 3, 1, 1, 2, 3, and just sort of visually follow that pattern, you're free to do that. The answer here is going to be y equals is a negative slope of 1 over 3x. And I get disappointed to notice that none of the points perfectly landed here. I can tell you that several of these actually do land at a nice number, so that's good. But if it doesn't, again, I'm going to quickly walk through that. The point I'm going to pick, I don't have really a double positive to pick here, but I'm going to personally choose, and remember, I'm not using the fake origin anymore. That's just to help me rotate it. I need to use the actual points here. So I'm going to use the actual point 2, -3 to borrow to find my plus b. So y I'm going to borrow is -3. Slope, the x I'm borrowing is 2, and I need to find plus b. -3 equals, this multiplies to be -2 over 3. And of course I need to add that to the other side. So positive 2 over 3. Once I move it, subtract 3. Need a common denominator, so this 2 over 3 minus 3, I need to multiply by 3 over 3. And this is 2/3 minus 9/3 gives me -7/3. So -7/3. Okay, so that is the correct answer if you're following along for your homework, number 4, part A. Okay, like I said, not all of them you're going to have to do this work to get that, but I do think it's good practice to make sure you are like excellent at that. All right, last problem I wanted to do was 6A. So I'm going to erase this just to give me some space and make this not look so crazy. And let's look at that. Because I'm doing 6A, it is also around the point 31, positive 90 degrees. Now this form is what's called point slope form. Now, like here, of course, when you go to do this problem, you can subtract the 4x over, divide by 2, just make it look like regular mx plus b form. And for all of these, you can give all of your answers in this form when you go to read it off. You don't have to try to make it look like these for your final answer. It's actually, that's a good thing. It's easier to just always write it mx plus b. So if I think ahead and I wanted to distribute this, you're going to get a fractional value here, like 1.5. I'm going to add 7 to that. And it's kind of an awkward spot to technically begin. And because it's 0.5, you might be like, oh, I can plot a 0.5 y-intercept and then count 1 over 2. But let's say it was like 8/7. Then you're like, well, where do I put that? So I don't want to just say because it's a 0.5, don't do it the long way. I wanted to go through the long way just to be safe. So point slope form is where you basically borrow this point that's hiding here, and from algebra 1, those were basically opposite sign. I'm not going to get into why that's the case right now, but this point is going to be at -3, positive 7. So you could go to -3, positive 7. And that is sort of like its y-intercept, but just somewhere else. It's a way to write a problem that doesn't have a beautiful y-intercept. The slope is up 1 over 2, so up 1 over 2, up 1 over 2, up 1 over 2. And again, you can notice, even though I drew that quickly, but the points do not land nicely here. So there would not have been a nice y-intercept if I had distributed that. Okay, so now let's do the actual problem. We've got our line on there. It's rotating around the point 3,1 according to what it said up here. So again, 3,1. This is my fake origin for right now. First point I'm gonna pick, wait, which way am I turning? 90 degrees counterclockwise. So I'm turning my head this way. I always gotta figure that out before I do too much else. All right, so this point's straight up, so I'm just gonna use that one. So it's straight up, 1, 2, 3, 4, 5, 6, 7, 8, 9. Turn my head straight up from this fake origin, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's do at least one more point. I'll pick the one next to it. That's over 2, or left 2, up 1, 2, 3, 4, 5, 6, 7, 8. Boop. Over 2, 1, 2, 3, 4, 5, 6, 7, 8. I like to check that the connection looks like a 1 and a 2. I probably did that right. And now that I have 2 points, I'm welcome to continue visually what's going on as many times as I want to. And I'm actually about to get super excited. Why? Because that is perfectly landing on the axis. So cha-ching, the answer to this one, the slope is negative. It is 2 over 1, so it's negative 2x. And that looks like one space above negative 10, so negative 11. Okay, so some of them are going to be a nice number. This example you saw earlier was a weird fraction. This video is running super long, but I did feel like it was kind of really important to talk through those problems and give you some of that extra homework recap. Again, quizzes tomorrow. I will be honest with you and let you know that some of this is not specifically on there, but it may or may not be when we get to the test that you'll need to know that. So I don't want you to panic for tomorrow if you don't comfortably know how to do this, but we do need to spend our Zoom calls maybe the next day, starting on Thursday, to talk about any of this that you're having trouble with. Okay. Here we go.